Hi, everybody. Welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book, and I've been talking about discrete dynamical systems for the last few lessons. This is my fifth lesson on them. And today I'm going to talk about what I think is a really fascinating discrete dynamical system, namely continued fractions. So, anyway, let's begin. So, I think continued fractions are a really fascinating subject. They're really, maybe I should skip to the next slide just to give you an idea what they look like. But here's a couple examples. So, on the left, we have the continued fraction of the square root of 2. And what a continued fraction is, it's kind of like a fraction where you keep expanding the denominator as a new fraction. And you can start with any real number you want. It can be rational or irrational. If you start with a rational number, you always get a finite continued fraction. But if you start with an irrational number, you always get an infinite continued fraction. So on the left as an example, square root of 2, as I think you guys all know, is irrational. Looks like they're really doing 1 plus the square root of 2. Well, they write 2.4. It should be 1.41421. So on. So I guess they are doing square root of 2. But I think you can see it has this nice pattern here. It is infinite, but all the continued fraction coefficients are equal to 2 except the leading one. If we started with 1 plus square root of 2, they would all be 2. And then on the right, pi, I think you guys all know that pi is irrational as well. And that means its infinite, its continued fraction is also infinite. But as far as we can tell, there doesn't seem to be any pattern to its continued fraction coefficients. They're kind of unpredictable. It started out 3, 7, 15, 1, 292, and we can't really predict what the next one's going to be in terms of the previous one. So those are a couple examples of continued fractions, but there's an algorithm for computing them. Just like there's an algorithm for computing decimal expansions of arbitrary real numbers, there's an algorithm for computing continued fractions. And here's the algorithm. You start with your seed, which is the irrational number you're trying to compute the continued fraction of. That's just an arbitrary number, A, I guess I call it here. And then what we do is we start with A comma R. R is, I guess I'd say it's an arbitrary non-zero real number. Oh yeah, R is the real number. A is an arbitrary integer. So then what we do is we replace A with the floor of R. That's actually our first continued fraction coefficient. A doesn't really matter here. It's just kind of a placeholder. But we replace A with the floor of R, and then we replace R with 1 over R minus the floor of R. And that's going to be a new real number that's greater than 1. And then we keep going like this. That's our new value of alpha of R. So then we compute the next continued fraction coefficient, which is the floor of this new number, which we might as well call R1. We get another A1, and you keep going like this. So you get continued fraction coefficients that are all positive integers. And like I said, if the number you started with R is rational, it'll terminate at some point. Otherwise, it'll keep going on forever. And I really like continued fractions. As a matter of fact, I think I have to make a video or a video series on continued fractions. I did a few days ago, or maybe a month or so ago, I did a daily math problem involving continued fractions. I might have even done a couple of them. But I think I'm going to maybe start a series on continued fractions because I really like them. I don't know. A lot of mathematicians consider them kind of archaic nowadays. I don't know why. My thesis advisor even told me he thought they were kind of archaic, but I think they're really fascinating. I think there's probably a lot of potential research that can be done on continued fractions. I know that Ramanujan really liked them, and a lot of other famous mathematicians have as well. Anyway, that completes my video for today on continued fractions, another what I think is a really fascinating discrete dynamical system. So thank you for watching. Long live math, and I'll see you guys next time. Bye.